All right, let's dive in. Today, we're going to take one of those exam questions that just looks scary. The kind they stick at the end of the paper to throw you off. And we're going to break it down piece by piece until it's not just doable, but actually pretty straightforward. So here's our game plan. We'll start by figuring out what the question's really about, then we'll grab a quick win with the y-intercept. After that, we'll hit the core of the problem, the turning point, and then put it all together for the final sketch. Let's get started. So here it is, question 23. And yeah, the first thing you see is that little letter p just hanging out in the equation. That's the part that's designed to look intimidating, to make you second guess yourself. But trust me, we have a process for this, and that p isn't going to be a problem at all. Okay, first things first, we need to decode the challenge. Any complex question is really just a bunch of smaller instructions mashed together. Our job is to pull them apart. And when you really look at it, this big 5-mark question is just asking for two things we already know how to do. Find the y-intercept and find the turning point. That's it. Once we have those two things, the sketch basically draws itself. Let's start with the y-intercept. Honestly, this is the easy part. It's a great way to get some points on the board right away and just build a little bit of confidence. Now here's a golden rule for any graph. Doesn't matter how weird it looks. The y-intercept is always where the graph hits that vertical y-axis. And what's true for every single point on that axis? The x-coordinate is 0. So, all we have to do is take our equation and plug in 0 everywhere we see an x. Now watch what happens to that p that was bugging us. 0 squared is 0. And negative 6 times p times 0, well, that's also 0. And boom, just like that, the first two parts of the equation completely disappear. All we're left with is negative 7. That's our y value. And there we go. Our first coordinate is 0, negative 7. Part 1, done and dusted. See? That wasn't so bad, right? All right, now for the main event, finding the turning point. For this, we need to pull out a really powerful tool from our algebraic toolbox called completing the square. It is specifically designed to uncover the coordinates of a parabola's turning point. Think of this process like a recipe. If you follow these 5 steps in this exact order, you're pretty much guaranteed to get the right answer. So let's just work through it together. Okay, steps 1 and 2. We look at the coefficient of x, which is negative 6p. We chop that in half. What do we get? Negative 3p. Perfect. Now we just put that inside a squared bracket right next to the x. So we have x minus 3p squared. Now for the really clever part. By making that bracket, we've actually added something new to the equation that wasn't there before. We added negative 3p squared. To keep everything balanced, we have to immediately take that exact same value away. So we subtract it. What's 3p squared? It's 9p squared. So we subtract 9p squared. And finally, the easy bit. We just bring down that original minus 7 from the very beginning and stick it on the end. And that's it. This is our equation in its completed square form. And this form is super useful. So why did we do all that work? Because this form is like a secret code. When an equation looks like y equals x minus a squared plus b, the turning point is just a comma b. You can literally just read the coordinates right off the page. So let's look at what we've got. Our a value is 3p. Remember, you always flip the sign from inside the bracket. And our b value? Well, that's all the other stuff tacked on the end. Negative 9p squared minus 7, and that's our turning point. Okay, deep breath. We did all the hard algebraic work. We have our y-intercept, we have our turning point, now it's time to actually draw this thing. Now, before we plot anything, let's just do a quick sanity check. Our original equation starts with a positive x squared. That always gives us a U-shaped parabola, a happy graph. That means it's going to have a minimum point at the very bottom of the curve. So let's bring our two key pieces of information together. We plot the y-intercept at 0, negative 7, then we mark the minimum turning point at 3p, negative 9p squared minus 7. Then all we do is draw a nice, smooth, U-shaped curve that goes through both of those points. That's our perfect sketch. So let's just zoom out for a second. What's the big lesson here? It's not just about this one question. It's about having a repeatable process for any question that looks like this. This right here is your strategic process. First, you break the question down into smaller pieces. Then you knock out the easiest part first to build momentum. Then you identify the right tool for the harder part, in this case completing the square, and you just execute the recipe step by step. This turns a 5-mark monster into a simple checklist. And that leaves us with one final thought. This idea of breaking down a big problem into manageable steps doesn't just work in algebra. So, what's another topic you're studying that seems really complex right now, but might just be one good process away from clicking?